Okay, for number one, we're just describing the effect of varying the parameters. Basically, just means changing the numbers for A, H, and K, and telling what that does to the shape and position of the graph for this equation. This is a quadratic equation. This is in vertex form, right? So when we look at these quadratics, I'm going to start with the innermost parameter, the innermost number first, and that's going to be that H part right here. So that value we've seen throughout the year, anytime you are adding or subtracting a value inside the parentheses with the X, that's what shifts the graph to the left or to the right. Shifting to the left or to the right. Now, it shifts to the left anytime we see X plus H, and it shifts to the right anytime we see X minus H in that parentheses, right? So if we saw X minus 5, that would mean the graph is 5 places shifted to the right. X plus 2 would be 2 places to the left. And the reason it's backward is because, again, in this form, in vertex form, it is X minus H. So if you are subtracting a positive value, that moves you to the right towards the positive X values. But if you're subtracting a negative value, well, then that's like you're adding that number to the X. That is what shifts it to the left. So subtracting -3 means it goes 3 places to the left. And again, usually that just gets simplified. Instead of saying minus negative, it just turns into a plus sign inside the parentheses. That's what moves it left. Then the A number in the front, just like with standard form and factored form, that A value that's written in the very front, it's not because it's that variable A. It could be, they could have called that C in front. But just know that anytime there's a number in front of the expression, in front of the X squared, that is what stretches or shrinks the graph. And it can flip the graph or reflect it. Okay. If that number, A is negative, if it's less than 0, then that's going to indicate that the graph is upside down, right? It opens down instead of opening up. Anytime it's a positive value, it opens up. But then that also stretches or shrinks the graph. So anytime, if you ignore the sign, so if you just think about the absolute value of the number, that's what those 2 lines on the side of my A mean right there. If the absolute value, ignoring the positive or negative, is bigger than 1, then it's going to stretch. It's going to be that many times taller. Or if the absolute value of that number is less than 1, so if it's like a fraction or decimal, something between 0 and 1, then that's where it shrinks the graph. And just to be clear, when the graph stretches, that means it looks taller and skinnier. Okay, so it looks taller and skinnier. Right. Anytime it shrinks the graph, it starts to flatten it out. And it looks, I think the better phrase would be like flatter. And it also makes the graph look wider. Okay, so just be aware of that. And then finally, the plus K on the end, that gives us a shift up or down. So anytime we add K, if it's a positive K value, it's going up. If it's a minus K value, it's going down. It's basically just going to indicate where that vertex gets shifted in this particular vertex form. All right, so that's number 1. I'm going to go ahead and do a number 2 as well. So number 2 tells me to simplify each expression. Part A, we've got 4x squared minus 3y squared plus 5xy minus 8xy plus 3y squared. Notice there's 2 groups of terms here. And there's nothing really happening with that first group. There's no number in front or anything like that. So we can always just rewrite a group of terms that's just being added or subtracted to another group. If the first group has nothing in front, just rewrite it without the parentheses, especially if we're trying to simplify, because that means we want to combine the like terms from the different groups. But then the second one has a minus sign in front. We got to be careful of that. So that means we subtract every term. And what that does is it changes the signs of the terms. If there's any terms being added, now they are subtracted. And any terms that were subtracted become addition problems. So Now we just combine our like terms. 4x squared is the only x squared term. Remember, to combine them, they have to have the same variable and the same exponents. So that one's done. I see minus 3y squared, and then there's another minus 3y squared. So that makes a total of minus 6y squared. And then finally, I have plus 5xy and minus 8xy. So positive 5 and negative 8, that makes a combined negative 3xy. So this will be my expression for part A once it's simplified. Part B, 5x minus 3 squared. Please, 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 please do not make the common mistake of just squaring this and squaring this. You can't just distribute an exponent if the terms inside are being added or subtracted. The only time the exponent is distributed is if you have something like 5xy squared, where everything inside is being multiplied. Then you can distribute and do 5 squared, x squared, and y squared squared. Simplify those, multiply them all back together. That's perfectly fine. But if you're adding or subtracting, that's not how you simplify these problems. This is where area models come in. So 5x minus 3 times 5x minus 3. We draw an area model to do the multiplication, just help us organize what all needs to be multiplied together. So we have 25x squared. 5x times negative 3 is negative 15x. 5x times negative 3 is another negative 15x. And then finally, negative 3 times negative 3 is positive 9. Now just write all that out, combining the like terms. 25x squared, negative 15x and negative 15x, those are both x terms. Combine those and you get negative 30x, and then plus 9. Now this one is simplified. And then finally, part C. 4 times x minus 2 times 3x plus 5. This is a factored form expression, kind of like part B. B had 2 factors that were the same, so they just wrote it as 5x minus 3 squared. But they could have written that as 5x minus 3 times another 5x minus 3. But in C, we have 2 factors that are different, and we also have a greatest common factor of 4 that had been factored out as well. So when we go back to multiply all this together, we got 2 options. We can either go ahead and multiply the GCF times just one of those factors, usually the first factor we see. You don't distribute it through to everything, because if you did that, then you're multiplying the first group by 4 and the second group by 4. You're basically multiplying by 16. So you just multiply that GCF times one of the factors. Or what to me makes the most sense usually is to just go ahead and just simplify this part first, then go back and multiply the result by that GCF of 4. So let's do it that way. So let's do x minus 2 times 3x plus 5. That gives us 3x squared, 5x, negative 6x, and negative 10. Writing that all out, we get 3x squared minus an x, because positive 5 and negative 6, those corners combine to give us just negative 1x, and then minus 10. So that is the expression for those two I multiply, but then I still have that GCF of 4. So now would be a good time to go. At this time, we do distribute because it's just a factor that's being multiplied, not an exponent at the end. So we distribute that and we get 12x squared minus 4x minus 40. Now that is simplified. Okay. So now we have number 1 and number 2 knocked out.